What's up, everybody? Welcome back to Make It and Break It. My name's Andrew, and today on our Project HyperTenere Yamaha R6 build, we get to go from placeholders like these to real parts like these. Alright guys, so what we've been working with up until today on this bike have been mostly guesses and measurements off of our original rear sets. So that's how we came up with kind of this design and the whatever design on the side that's kind of underneath the camera right now. But these were all just preliminary stuff, and they're like 85% models, meaning like 85% good or 85% complete, because we didn't have the parts, the final parts, to check everything before we sent them off to the machine shop. Now though, we can transition from using these placeholder bits, like this brake pedal or this foot pedal, foot peg, to, oh come on, transition works so much better the first time I tried this. Real parts. So we got our real parts in. Finally, these Pivot Pegz took a while to get in. There was some shipping snafu or something. Not Pivot Pegz's fault, it was probably America's fault. But we have our parts. So we now have our actual brake pedal. This is a Zeta Trigger brake pedal. It's spring loaded, so if you hit it here, it'll fold back and stuff like that. We've got our shifter toe boot, folding toe linkage for a from Woodcraft, and so we can check this out with our positioning and make sure that that works fine. And we've got our Pivot Pegz. So these are Pivot Pegz. These are a Yamaha Super Tenere 1200 version of the Pivot Pegz, and these things are really cool. So most pegs, foot pegs, in fact I think pretty much every foot peg that I've seen, pivots in at least one direction. So let's say you're coming up and the bike hits the ground. If the ground comes up and hits it, it'll pivot up like that, and it'll pivot up and away and fold away and basically take some of the shock out of loading straight into your chassis. Pivot pegs are cool because they have a second axis of rotation. So not only do they pivot up and away like this, but they also pivot side to side like this. You can see kind of the slot where that happens. And that helps you off-road. If you're shifting your weight around, the peg will stay flat underneath your boot, so you have a little bit firmer and better foot controls, as well as easier time reaching your brake or your shift lever or anything like that. So these are really cool. But while I've been in contact with the manufacturer and I got a lot of measurements for these things, like this width here and kind of this offset from you know, this hole to this strike plate area, what I didn't have was this angle. And so this angle of this mount, so normally this will mount, if this is straight up, it'll mount like this, so when it hits the ground it goes like that and pivots up and out of the way. I didn't have that angle. I think it's a 45, but we're gonna check that. And then we'll get our final 95%, hopefully, models into the computer on the 3D printer and bring them back out of here. So let's get going. First place we gotta go is over to the bench. We're gonna do a couple quick measurements and validate what angle we need. Okay, so we're here on our bench with one pivot peg. I'm making an assumption here, which actually, hold on, I probably shouldn't make. Let me get the other one. So we're here on our bench with both pivot pegs now, and the idea here is we're just trying to validate what this angle is back here. So this thing is offset, you can see, trying to validate that angle. So we've got a pretty simple thing. We've got our magnetic kind of angle finder. Use this in a lot of fabrication, roll cage tubing, all that sort of stuff. You can use these things to kind of find angles that you need. But the idea here is we're checking this. So this is approximately 0, so at least this table is sort of straight. And then we validate against this. So this right here is also approximately 0. So this is flat on the bottom. And because it's sitting like this on the top here, we're making the assumption that this top is also flat. So there's a couple of assumptions here, but I think they're pretty good. And then you just go like this, set the magnet on this part here, and see what you get. So if we go down here and look, we're maybe just a little bit past 45, but it's essentially 45 degrees. And then on this one, we'll do our little look again. Move this over. So on our other side, we are essentially at 0. Wants to spin on me for some reason. And then we go like this. At 45. You know, these are plus or minus 1 degree measurements. This is not the most accurate way to do it, but it's pretty close and it'll get us in the ballpark. So kind of what we thought, these things are on a 45 degree angle. So you need to build your bracket at 45 degree angle so it grabs, so it has holes here. So this part still mounts flat, but it'll rotate up and work pretty well. So that's what we're gonna do. So let's hop into CAD. This is SolidWorks 2017 or 2018, whatever it is. I think it's 2017. And we're gonna walk you through the changes that we made. So this was the old right side mount. So this would be your brake pedal side mount. I'm only gonna show you the brake pedal side. The clutch side has largely the same modifications. It just you know, doesn't have everything that we did here, and this has most of the modifications that we did. So but this was our original design, and so you can see this was designed with bolt-in style pedals in mind. These are the style pedals that are really easy for us to manufacture for testing, and it's not super complicated and doesn't require a whole lot of adjusting. You can just delete this circle and draw whatever you need to in this area in order to get everything ready for actual real fabrication. So the idea here is that we had bolt-in style mounts for testing, and we also had this stuff set up back here. This is a problem because when the master cylinder was mounted here, so it gets mounted on this face in these two holes, the new sensor we installed for the rear brakes actually extends out this way and would contact the rear swing arm if it was highly compressed. So we wanted to get rid of that, and we needed to get ourselves more space here. This is about ½ an inch thick. It's definitely thicker than we need to have it here. It doesn't need to be nearly that thick to be strong enough to hold the master cylinder in place. And the idea here is that it probably won't take too many hits, so it doesn't need to be super thick overall. And so when we made our adjustments, we have our V4 prototype here. So first things first, at the brake master cylinder, you see we made this. This is a 1/4 inch now, so hopefully that gets us enough space. If not, we can always adjust that a little bit more. That's not a big deal. So the second thing we did is, you can see there's no mounting hole here. So this is the mount design necessary for our pivot peg. So our pivot pegs will mount in here. It has a dowel or a pivot pin that goes through here, and then it's a lot like how our brake pedal mounts now, with a dowel that goes through 2 holes, and it has a cotter pin on the back side. So that's what's going to go on here, and then this little part here is for a strike plate, so something that our pedal actually hits against, so that it stays in place when your feet are on it. Otherwise it would just swing all over the place and be really unstable and terrifying. Also, it'd probably rip this pin out. So this is angled on the right side, so this is brake side, so it's angled with this is forward, such that if you hit going forward, the pedal will fold up at about a 45 degree angle. That's from our measurements earlier. And then the other adjustment we had to make here is, because this moved, the actual center line of this moved a 1/4 inch that way, we have to change our brake pedal. So our brake pedal, new brake pedal V4, if you go look at our old one, maybe I'll show a picture here, if not, whatever, you'll see that this face is actually, this face, which is continuous right here, was actually split. So everything that was on this tab actually was a 1/4 inch in this direction, over here. And because everything moved out, luckily it worked out. This was actually offset just a 1/4 inch, so I could just reference everything. I wouldn't have to redraw it, so that was nice.
hopefully this all works. So this will be our new brake pedal. You can see how this works out. So these are 4 holes that are roughly spaced based on the spacing in our trigger brake pedal, and they will be threaded such that we can install our trigger brake pedal mounting screws to these things and fix it in place and give us a little bit of adjustment, you know, 1 or 2 holes across. So I've already put these things on the printer, so we're going to go grab them off, make a couple little reaming operations, and we'll see you back at the bike.
Okay, so we're back and assembled, and so far everything's looking pretty good, but there are a couple problems, and I do want to show them to you. First, everything fits together pretty well once I ream this out, because this fit that I put in the computer for this bolt, this is a shoulder bolt for the other side. I'll show you why that one's not installed right now. It's a shoulder bolt and then a wave washer to take up the space. Everything there works pretty good. You see there's still a lot of flex up here. The other thing to notice is because we thinned this out, these stick out a lot, these bolts that are holding this on. So smaller bolts, shorter bolts would be in order for this type of installation with these much thinner mounting points. But it rotates pretty well. And the position's also pretty good, except for 1 or 2 things. First, the back side here on the master cylinder sensor is still very, very close to the swing arm. And if the swing arm were to go all the way up, I am still concerned that it would get impacted. So that's concern number 1. Concern number 2 is, well, this. So this is our pivot peg, and it's in here, and these ears look pretty good actually. It's a pretty good fit. I might want it a little bit closer, so I'll measure that and see what it actually came out on the printer, and then make sure my drawing gets updated to match. But here's pivot pegs, and this is what makes pivot pegs really cool, is like when you're changing your weight around, it'll actually rotate, you know, plus or minus 20 degrees, and that's this rotating, not the whole plastic piece. So that's what makes these things really cool. And then this is, if it were to go down, it comes up. But here's the problem: when it comes up like this, it's not hitting the stop that's on the shoulder right here. So there's a little shoulder here, and then there's a shoulder on the bottom for where they're supposed to contact. You know, it's like a shoulder like this, so it comes down and hits on the main mounting plate. Problem is, it's not contacting that. It's actually hitting this tread piece here, is hitting our bolt head, which is not good. So what that does is that instead of all the force of an impact going in and transferring along that shoulder here, like that, it's transferring all of the energy through this one point of tooth right here on this thing into our bolt for the brake pedal. And that's going to cause issues for damage. We might bend pins or get bolts like this stuck in there. A lot of things could happen. We could use a smaller headed bolt like this, or grind down our bolt head. I'm not sure if this will fit though. Let's see. Well, I mean, this will all thread in. I'm not sure if this will make the difference. So let's see here if this does make the difference. Nope. So even one of these very low profile head bolts doesn't work very well. So with this contacting problem that we have a couple solutions, and I prefer one over the others, but we'll kind of see how it plays out. First solution is to actually put a countersink into the brake pedal here. What that can do for us is let us recess the head of this bolt in farther and hopefully let that clear the foot pedal. A couple problems with that. One, it starts adding stuff on the back side, which makes fabrication a little bit less fun and a little bit messier and more expensive. Two, all of this stack up is kind of designed with this bolt in mind at this sort of standout. So requires a lot of redesign of a lot of this assembly, which I'm not necessarily excited for. I'll do if I have to. Another option, and the option I think I'm going to try first, is to actually extend our foot pedal mounts out. Right now, these foot pedal mounts are in here, and they're narrower than we were originally using with kind of our placeholder assemblies like this one. And so the problem is if we put a boot up here, it actually will impact some of this here before actually getting to this pedal. And I think I'm gonna have to adjust where this pedal lands to, just based on looking at where it's all landing based on this foot pedal. Because I had this foot pedal being much larger and in a slightly different location than where this one's actually sitting. But if we were to extend this out another ½ inch or so, that should be plenty of clearance to make sure that this hits a stop and we can put that stop in there. But it also is plenty of clearance to now move our boots out, give us a slightly wider stance, and clear a lot of this stuff that we've made to clear the all the workings of the bike over in this area. So that's, I think, how we're going to attack that first. Moving the foot pedal also addresses another clearance issue, and that is the brake pedal to this mount. So the original mounts were a lot smaller and I had more movement of brake. But in order to get the brake light to actuate, which you can do if you hold this in place and then actuate the brake pedal, in order to get that to actuate, you actually have to go past where this nut is, and this nut is thicker than the head of a dowel pin, but it's not that much thicker. So in order to get the brake lights to actuate as it sits, which is not amazing, there's definitely room to improve because this is short a lot of brake fluid. But in order to get that to actuate, it has to go fully flush with the mount here. And well, that's not awesome, and we can't even get there right now. So by extending the mount out farther, we can let this have more space outside of or next to the dowel pin head to get more brake motion out of the brakes. Now, I do want to confess to something on the left side, which I'm not going to go to right now because there's not a whole lot to look. The clearances are pretty close, but I did forget something major. This is our old test assembly, and if you think back to the parts I pulled off, there's a hole missing. It's in fact this hole that we used to mount the actuator, the gear shift lever. I forgot to put that hole back in when I was redesigning this for this new piece. So yeah, I can't really fully check that side, so we're gonna have to print a new one over there. But the clearance on the bottom is very tight. That's what I was kind of worried about. But if we're moving everything out, there is some room to shave off the backside to get our clearances back in, so we're not impinging on our side stand that we fixed a couple of episodes ago. But that's why this isn't installed and we're not looking at the left side right now, is because there's not a whole lot to look at until I go fix that problem. So we're gonna go back to the drawing board a little bit, try and address some of the issues with this right side and the left side. We'll bring it back when we've got the new parts to try again. Okay, we're going hand cam here. First, I want to remind everyone that plastic, especially PLA like this, when it's printed thin for prototyping purposes, is not super durable. That's how this happens. So this was the left side mount, which was sort of working. There were a couple issues that I got fixed. But I was testing out shifting and how it felt, and it broke. and you can see that because it's basically hollow, and that's so that it actually prints faster, but it means it's not gonna be, you know, tough. So just when you're prototyping, don't put a bunch of stress on your prototype parts. They will break and then they become useless for you as prototyping parts. Now, we're looking at our right side, brake side. We've been using this because it's a lot more complex. You can see that stuff is looking pretty decent. As we come out here, you can kind of see how everything's lining up decent. First thing I noticed though is this seems to be coming out a little bit. It's not quite perfectly perpendicular. So one thing we adjusted on this brake pedal is we actually made this tab. We moved the entire brake up some and around, so we made this tab more straight out. That gives us more straight up throw on the brake master cylinder. But we have created an issue here where this plunger is not going straight up into the brake master. It's kind of canted off to the right a little bit. Luckily, I didn't fix the clearance issue back here, so we're going to take like another 1/16 of an inch off or something like that. That should line this up and maybe give us more clearance back over here. At least enough that I'm willing to try it out. But the other issue we're noticing, and this is kind of an issue of foot placement. So we have our boot here, and it goes right up here, and actually I did put my feet in these positions with the seat on. I did put the seat back on and put this mostly down in its position. This is actually a pretty comfortable riding position, believe it or not. I think we're going to want to flatten the seat out, like lift the front of the seat up a little bit more to make it easier to stay in this position when you're sitting. But as far as like my legs and everything, this is actually a pretty comfortable position. Problem is, with as much clearance as we've tried to make here with the brake pedal, and we have readjusted how this brake pedal actually sits, what actually happens is, when you're standing here with your foot on the brake, you're actually pushing on this, not on your actual, you know, brake pedal toe piece. And that's not great. I mean, the whole point of having one of these is you can keep all of this stuff away from your foot, and if you're just stepping on this, all you're going to do is rub everything. We have a couple options to kind of fix that, and I'm going to go try out a couple of them with another print here, and we'll have a couple options, see what version we like. First, I'm going to print a new one of these with more protrusion of these foot pegs. So right now we extended these foot pegs out 1/2 inch. It is a little far. I don't really want to, you can kind of see how it sits here. Right now this goes up and it doesn't hit anymore, so we got rid of that clearance issue. But if you're looking down right now, our foot pegs are one of the farthest out pieces, and that's in a fall going to put a lot of stress on this piece here, on this whole metal piece. Now it should be fine if we extend it out even just another 1/2 inch. It might look a bit weird though. But that would put, if we extend it out another 1/2 inch, that would essentially put us along this line for our boot and make this toe thing the furthest out and the most comfortable thing to hit. The second thing I noticed is that this is still, I think, a little too long. So if we put the boot up here, kind of in a normal riding position, you can see the brake is right here sitting under our toe. And I think I want it to be in this way a little bit farther. So I think I'm going to shorten that up again, and if you can see, it's barely at the end of the toe at like a normal sort of foot position on the peg. So I think I want to bring it in a little bit more, maybe another 1/2 inch to 1 inch or so. So we're going to shorten up that too, which should strengthen up the pedal overall, even if it makes it maybe a little bit more abrupt on the brakes. And then the other option here is to actually take this and push it in farther. So right now the brake pedal goes straight out, goes down, comes out to the left a little bit, and then it mounts up. So this brake pedal design seems like it worked really well if the pedal was out another 1/2 inch, because then it goes from your boot hitting this to your boot coming up and hitting this about there. Maybe a little bit shorter, but we'll leave it there for now. But the other option is to shorten this up, make this a much shorter brake pedal, and make it a much thinner brake pedal. So we have just a small little section out here for putting your toe piece in. So I think I'm gonna print one of each, and so I'm gonna print a new brake pedal that is shorter and thinner, doesn't have all this much gapping out here. And I'm gonna print one new mount, one new right side mount, this main mount piece here, that's extended out a little bit farther, and see what happens. That's where we're gonna go with this. So more time on the computer, another printout, and we'll see you guys back here hopefully with our different options. Well, all right, that was actually pretty successful. So what we ended up doing with these is we ended up extending, where's the old one? Here it is. We ended up extending the mount out another 1/2 inch. So instead of 1/2 inch, we have 1 inch extension out from the main mounting plate. And then what we did here is we cut reliefs for clearance on the bottom side here. This is mostly for the left-hand side. You saw me putting that together, and it actually mostly clears the kickstand. There's a little bit of scoring here, but that's something we could you know, grind out and buff out at the end piece once we have everything finished. But otherwise, everything seems to line up pretty well. I did not listen to myself on the left-hand side. You saw me break this on the time lapse. But this is, yeah, this is supposed to look like that, and I broke it. But left side fitment works pretty good. I did notice that we are going to have to move the coolant expansion tank, coolant bottle, whatever we're calling that thing, that's probably gonna have to move up or forward, probably forward. I'm gonna see if there's something online about people who have relocated the expansion tank for other reasons, because there's not a whole lot of good mounting points for it, but we could always custom fab something for that anyway. So either way, left side looks to be pretty good, but we're gonna have to move the expansion tank so that we can actually get the movement we want out of our shifter here. On this side, you can see everything sets up pretty good, and I actually kind of like how this sets up. So previously, it's hard to get it to stay where you really want it. Previously, when it was in 1/2 of an inch, this toe was actually sitting underneath this is your clutch line lever. So this is what actuates your clutch right here, and that runs all the way up over into the handlebars. But it was sitting underneath that, and that was just asking for me to get in here and interfere with the clutch and all sorts of stuff. So moving it out has helped clear the boot away from that, as well as cleared the boot away from the brake pedal. So one of the things we were struggling with earlier is the boot was actually contacting this front part of the brake pedal before it hit the actual pedal that we want to hit ourselves. So this moving it out actually does a really good job of clearing everything there. So we can actually simplify this design a little bit more, and this location is pretty much where I want it. So we can simplify this design a little bit more. I'm not necessarily gonna print one out, but we'll simplify this for the final product, which we're actually pretty close to doing. The other thing I noticed is that this seems to have worked, moving it 1/16 of an inch. So that seems to have worked appropriately, and everything lines up pretty well, and the brake actually actuates better like this than it was previously. So it looks like that solution has also worked for us. So all around, and we've even gained ourselves a little bit more clearance from the exhaust on the backside here. So one of the things I was worried about on the backside is our heel to exhaust distance was very close when we were getting in close, especially before we started spacing out the foot peg mounts. So now that we've spaced the foot peg mounts out, there's not a whole lot of worry about too much contact between the back of my heel and my exhaust over here. And I can just put a little, kick plate, something to protect the exhaust from my boot, and we should be good to go. And these positions are pretty comfortable. I did check that off camera, and they're pretty good. They're good enough that I'm comfortable moving forward with it. So it looks like we actually finally have final designs for our foot controls. It's been a long time, but I do want to stress, this is why if you're custom making stuff and you're custom making it with parts that aren't here yet and you don't have drawings, you really do need to fit everything up after you have the parts together. Make sure that everything works together. Otherwise, we'd have gone away. I had all the measurements and I had a rough idea of this angle before I ever got these foot pegs. So I could have drawn this, and I probably would have gone with our original mount here, like this, which had huge issues if I were sending this off to the machine shop before I had this foot peg in here to check clearances. So you really do need to take your time when you're custom building stuff like this. Even 3D printers are really handy, but they're not magic. They don't create things that you don't have the model for. So I didn't have the model for a lot of these pieces, so it was hard for me to fit them up and check all their fit. So now that I have them, I fit them up, everything looks pretty good. So it's pretty much time for us to send this off to the machine shop. So I'm gonna go get doing that and leave you guys here. So thanks for watching, everyone. My name's Andrew. This has been another Make It and Break It YouTube video. If you like this video, hit like. Comment down below if you have questions, comments, concerns. If you want to know where I got these parts, there's going to be links in the description down below. They're probably going to be Amazon links where possible. Just in case you follow them and you want to use the parts, it does help support the channel. If you like the channel, if you like what we're doing with our Project HyperTenere, some cool 3D printing technology, 3D printing prototyping, we've got a Project Doritos Locos RX-8 out there that's got a broken clutch I'm going to fix here in the next couple days. So that sort of videos coming out then definitely hit subscribe, ding that like bell. Ooh, like bell, that's not a... Ding that bell so you get notified when we put out a new video. Thanks for watching, everyone. Again, my name's Andrew, and I'll catch you later.